So today we're going to talk about mean distributions, and unlike the proportion distributions, the mean distributions are quantitative data. And we're looking for x bar, and we know we take all of the data, we add it, we divide by n. And so what we expect is that when we try to find the average of x bar, we should get the average of the entire population. However, when we take the standard deviation of x bar, what we're going to find out is that the standard deviation is going to be changing, and it's going to be the standard deviation divided by the square root of n. The reason being is because the more data for the average, the spread should get smaller. And so in class we talked about how this happens and why this happens, and it happens no matter what, as long as the trials are independent, as long as everything's independent. So let's say we have an IQ test where the mean is 100 and the standard deviation is 15, and for these problems, for right now, we're just going to say that they're approximately normal, so I should put approximately in here. Normal, and probability that we pick 10 people and that the average is above 105. So here's my normal curve. We predict that the average should be 100. The standard deviation should be 15 divided by the square root of 10, which turns out to be 4.74. So now I'm going to have x bar at 105, and I want to know the probability of getting in here. So first we find the z-score, which is 105 minus 100 divided by this 4.74, and we're going to get something slightly over 1. So we got 1.054, and so now we want to know the probability that z is bigger than 1.054. And so once again, you can either use a table or I suggest normal CDF, and we get 0.146. So that's the chances that we get above 105. Let's do one more. So I'm going to use the same scenario where we picked 100 people, and we want to get the average to be below 97. And so here's my normal curve again. The mean of x bar is still 100, because it's always 100. And the sigma of x bar is 15 divided by the square root of 100, which is 1.5. So 97 is right here. So x bar equals 97 down here. And so I'm going to shade in this part. So first we find the z-score, which is pretty easy for this one. 97 minus 100 divided by 1.5 equals -2. And so the probability that z is less than -2 turns out to be 2.2%, or 0.02, I should call it 3 if I was rounding correctly. And so what you notice is that in this problem, 97 was only 3 below, but we had a very small percentage because we picked more people. On the last example, we had more people, or we had less people, so it was easier to get an average farther away from the mean. And that's going to be it for this particular lesson.